in previous sections. Okay, so now in 12th standard you must have learned about Ohm's law. Now we all know what is Ohm's law over here. In order to apply Ohm's law, we should know over here that whenever a wire is connected between the two terminals, that is between terminal A and terminal B, if the potential difference in A is greater than potential difference in B, then what is going to flow? That is, a current is going to flow from a higher potential to the lower potential. So the direction of the current is towards right, and the direction of opposition to the current, which is called as resistance, that is towards left. So a resistance is also a kind of friction. So here this is, things are quite clear. If the current is going towards right, then the resistance is opposition to the current, which is called as the resistance, opposition to the flow of current. Next part over here, which we'll see, that is actual friction in mechanics. So in mechanics, if a body is traveling towards right, then the frictional force will be towards left. So this is the applied force and this is the frictional force. So we can infer from this that if this is the direction of motion, the frictional force will be opposite to the direction of motion. So let us write down definition of friction. So frictional force is defined as a force which is always opposite in a direction of motion. So it is always opposite in the direction of motion. So if the direction of motion is towards right, then the frictional force will be towards left. So this is a frictional force, this is the applied force. Now we have seen what is definition of frictional force. Now let us study few things in detail related to frictional force. Supposingly there are two bodies which are in contact with each other. So this is one of the body and this is the other body. So this is the horizontal floor which is in contact with this body. Supposingly this is body A. Now we are applying a force that is towards right. This force is called as the frictional force, not friction force. This is the applied force. The frictional force will be in the opposite direction, that is Fr. Now let us understand how this friction force works. So over here we'll draw a graph of this frictional force versus applied force. Now over here in this diagram we have seen that we are applying a force. We are applying a force along horizontal direction, that is towards right. So this quantity over here is dependent upon us. So that should be on the x-axis, which is also called as independent axis. And this force should be called as applied force. So this is the applied force. Now on the y-axis, once we apply this applied force, opposite to that we have the frictional force. So this frictional force over here is directly proportional to the applied force. So what happens exactly? If we have a body A over here and we are trying to apply a force, so this force will be applied. The magnitude by which this applied force increases, the same magnitude by which the frictional force also increases. So that means the applied force is directly proportional to the frictional force. So we can write over here P is directly proportional to R. So that means on our dependent axis over here, that is a dependent axis, the force should be the frictional force, because this frictional force is dependent upon the applied force. So that we have taken into consideration, that is frictional force. This applied force is directly proportional to the frictional force. This force is the force which we can control, and this force is dependent upon the applied force. Since it is directly proportional, the graph will be a linear graph passing through the origin. It will still increase, and it will reach to a value called as maximum frictional force, or it is this is also called as limiting frictional force. Till the point of limiting frictional force, this applied force is directly proportional to the frictional force. Beyond that, if you increase a small amount of force, the frictional force decreases. Now, from this point, the point of limiting friction, or this point is also called as the point of limiting friction. Before the point of limiting friction, the body is in static condition. Beyond the body line of limiting friction, the body becomes dynamic. Now let us understand this in further detail. In 12th standard, you must have studied thermodynamics. In thermodynamics, you must have seen what is a reversible processes. So let us just quickly revise what was a reversible process. So over here, supposingly this is a cylinder. Inside this there is a piston. You are applying some force over here. This force was called as the driving force. And on the other side, this was called as the opposing force. Now this is how a reversible reaction is defined. So if you the difference between the driving force and opposing force always tend to zero, or it was almost equals to zero. That means the driving force was infinitesimally greater than the opposing force. Now by small amount, if this opposing force increases, then the entire entire reaction reverses. Now initially, since the driving force is greater than the opposing force, this will go towards right. And if the opposing force increases by a very small amount, this entire reaction reverses. This is called as a reversible reaction. Now what is its analogy over here? The analogy of this reaction over here is very simple. Now, if we increase the frictional force, we come to this point. This point is called as point of limiting friction. If beyond the point of limiting friction, if we further increase the applied force, then the body will go from static condition to dynamic condition. That means the body which was stationary now has started moving. So this point is important. That is called as frictional force. That is the very example which I gave you over here. Small amount of increase in this opposing force, the reaction, the entire reaction reverses. Small increase in the applied force, what happens? The body goes from static to dynamic condition. So this graph is quite important over here. On independent or x-axis we have applied force, on dependent or y-axis we have force. It is directly proportional to this point. Beyond this point, that part will be going from static condition to dynamic condition. So we have seen this graph in detail. We know what is a reversible reaction. The best example, one more I can give you, is of static to dynamic is if you set an alarm in the morning at 5 a.m. So exactly when the alarm rings, you do not get up. Okay. So there will be 2 or 3 minutes delay. Between that 2 or 3 delays, you are always thinking that